In our daily life, this term called work is very loosely defined. For example, me recording this video right now, I could say I am working. But my brother could look at me and say, hey, no, he's just playing on his computer. He's not working at all. See what I mean? Loosely defined, hard to agree whether somebody's working or not. But in physics, we want precise definitions. So in this video, we'll see how do we define work in physics. So according to physics, work done on an object equals the force on an object multiplied by the displacement of that object. So this immediately means that if you want to do work, then one, you need to push on it, push or pull on it, because you need to provide a force. And while pushing or pulling on it, you have to make it move. That's the condition to do work in physics, okay? So you have to push on an object, because if you don't push or pull, the force will be zero, work will be zero. And while pushing, you have to make it move, because if you don't make it move, there will be no displacement, and again, work will be zero. So let's quickly look at some examples to make more sense of this. Imagine somebody is pushing a grocery cart on grass apparently. Do you think that person is doing work on that cart? Well, let's see. Since she's pushing on that cart, she's putting a force on it. And notice, while pushing it, she is making that cart move. And so she's putting a force and she's displacing the cart. Therefore, she's doing work on that cart. On the other hand, what if there's a person who's trying to push on a wall? Do you think he's doing work? Well, let's see. Again, since he's pushing on that wall, he's putting a force on it. But that wall, it's not moving anywhere. The wall is just staying there. So he's not making that wall move. So he's putting a force, but he's not making it move. So he does not do any work over here. Now he might say, hey, no, I got so tired by pushing that wall for 3 hours. It doesn't matter. He didn't make it move. He didn't displace it. And therefore, no work was being done. All right, let's take another one. Let's go to outer space where there is no gravity, no friction, so that we can keep things simple. Imagine we have an astronaut with a ball in his hand. Say he throws that ball. Do you think he did work? Think about this for a while. All right, let's look at it. When the astronaut throws the ball, he's clearly pushing on that ball, right? To make that throw. And while he's pushing on that ball, notice he is displacing that ball. He's making it move while pushing. And therefore, he put force and he did displacement, and therefore he did work on that ball. But what happens once the ball gets thrown? Do you think now he's doing work on that ball? Think about this. What do you think? Well, if I get that back, once that ball is released, notice he's no longer pushing it. So yeah, the ball is moving, the ball is being displaced, but now nobody's pushing on it, right? And so now no longer work is being done on that ball because there is no force acting on that ball. Remember, we have to push it and while pushing, make it move. So the astronaut only did work when that ball was in his hand. The moment the ball started moving away from his hand, no longer work is being done by that astronaut. So this is fun, right? Let's do more examples. This time imagine a man who's just holding a barbell like this and just standing there. Do you think he's doing work? Well, let's see. Is he putting a force on that barbell? Yes, he is. He must be pushing up on it, right? Otherwise, due to its own weight, the barbell would have fallen down. So he's balancing the weight of that barbell by pushing up on it. So he's putting a force on it. But he's just holding it over there. So do you think he's doing any work? I'm pretty sure you can now answer this. No, he's not doing any work because he's not making that barbell move. Now, of course, he might say that, just standing like that, he's getting very tired. He starts sweating profusely and he's getting super tired. But just because you're getting tired doesn't mean you're doing work in physics, and that's important, okay? So yeah, he's not doing any work because he's not displacing that barbell. On the other hand, now imagine if he starts moving that barbell up, now he did work because now he pushed it, and while pushing, he displaced it. Okay, one last example. Now let's say we take that same barbell and we just drop it. Now do you think there was work being done on that barbell when it was falling down? Think about this. All right. At first, we might say, no, there's nobody pushing on it. So clearly nobody's doing work. But remember, to do work, you just need a force. People don't have to push on it. Any force will do. And you might know there is force of gravity pulling down on it. And that's why it's falling in the first place, right? So gravity is pulling down on it. And as it's being pulled down, notice it is displaced. It's falling, so it's moving. And therefore, work was done on that barbell. It was not done by people in this example, but it was done by gravity. Any force can do work as long as it can displace that object. It doesn't have to be living things. Okay, now that we know when work is being done in physics, let's go ahead and calculate work for a particular example. So let's say this lady pushes the grocery cart with a force of 30 newtons and displaces it by 2 meters. S is the letter that we use for displacement. What is the work that she does on that grocery cart? Can you try and answer this question? Okay, work done is force times the displacement, right? So in our case, the work done will equal to force, which is 30 newtons, times the displacement, which is 2 meters. So that gives us 30 times 2 is 60. And now let's look at the units of this. The units become Newton into meter. So the units of work done becomes Newton meters. Now, because work is something that we'll be using in physics over and over again, we decided not to write Newton meter over and over again. So we gave Newton meter a name. We call Newton meter a joule, given by capital J. So capital J stands for a joule. It's named after a scientist. And so the unit of work done is also joules. So over here we can say she did 60 joules of work on that shopping cart. Now before we wrap up, one question you might have is, what is the meaning of Newton meter? What does it say? Or why do we even define work as force into displacement? Where does it all come from? Well, we can only answer this in the future videos once we start introducing energy and we start connecting work and energy, and then it'll all start to make sense. Okay? But as of now, in this video, what did we learn? We learned that in physics, work is force times displacement, which means that to do work, you need to push on something or pull on it. And while pushing or pulling, you have to make it move. Okay? We also saw its units turns out to be Newton meter, and Newton meter is often called joule. So Newton meter or joule is the standard unit of work.